All right. So we have Ananya, Arya, Aryan, Dev, Chris, Neil, Ritika, Sarah, Shravya, and Srivatsav. So few of the kids are missing. There could be a possible reason for that because I know not summer break. The Thanksgiving break has started. Some of you might have planned for travels, so that could be the reason. But we'll actually get started. So before we start, just an information for you guys. Today and tomorrow we'll have the class. Saturday and Sunday we will probably skip. The next Saturday, Sunday. That is when I'll be out of town. So that will be the only break that we'll have. But what we'll do is once you guys are back, we will have a quick test. Or when we say test, it'll be more of a reflection of what we have learned so far. And the kids who are here in town in Dallas area, I would request you guys to be in the classroom, and kids who are remote, we will try simulating the test like environment where you guys will be solving the problem on the fly, and then with the videos on, and we'll see how much we remember what we have learned in the past, and this test will become a monthly exercise where we will just try doing a reflection of what we have learned, how much we have retained, what has started disappearing, so that way we can keep a close tab on our learning journey, and anything that we end up missing or forgetting or not being able to recall, we will go back to those concepts and keep pressing them out. So without further ado, let's get started with today's class. And if you guys got a chance to look at what are the topics that we have for today, I'm planning to talk about linear equations and inequalities, and then we'll look at some of the properties of the linear equations and how do we relate them, how do we deal with them, how do we come up with a methodical way of representing them. So are we all set? Shall we start? Okay, all right. So first of all, everybody knows what is a linear equation. I would not want to go into the complexities, or I would not try to repeat myself. Any equation that is in the form of this is a linear equation. Why linear equation? Because this plots a straight line when you try plotting this on a graph. And the way to recognize that would be that the power to the variables a and b, x and y is 1 and only 1. And that's the only reason, that's the only circumstance under which you will call this a linear equation, where a is called the coefficient of x, b is the coefficient of y, and c is another constant that is just lying there without a variable. This is called the standard form of linear equation. Are you guys with me so far? We have talked about it in the past also. So any equation which has two variables, x and y, the power to the variable is 1, and it can be represented in this form is a linear equation. So if I look at 4x plus 3y equals or minus 6 equals 0, this is a linear equation because the power to x and y is 1. This is a, this is b, and this is c. Similarly, why 4x always? X minus 7y plus 12 is also a linear equation. Again, same thing, power to x and y is 1. Now you guys will think that why the teacher is wasting so much time talking about something that we have already talked in the past, right? And that is not the intent. This class is not free in the sense free from learning. So let's come to what we're trying to learn here. So if you have, let's say, two equations like this, and then you have another equation, let's say 3x plus y by 2 minus 11 equals 0. What are the different possibilities that you can think of? If I have these two equations, we know that these are linear equations because the power to the variable is 1. Here also, power to both the variables is 1. Both are linear equations. Meaning, if I will try plotting them on a graph paper, both will make straight lines like this, or they can make lines like this, or any which way. So they will plot a line for us. Are you guys with me so far?
Yes, sir.
Now, I'm going to the next level and asking you guys that, okay, these two are linear equations and they will plot a straight line. That is given, that is understood, that is agreed. Now, if I have a pair of linear equations, what are the possibilities we are talking about? What all could happen? They could be parallel. So one response I'm getting is they could be parallel, meaning when I plot them, they could go like this, or they could intersect, or it could be perpendicular. But again, perpendicular or intersect are the same thing. In both the cases, it's intersecting. We are just not trying to worry about the angle right now. So one is they can be parallel, that is one relationship that is possible. Second relationship where they can intersect at one point. When they are not parallel, they will intersect. And there is a third possibility also. What that could be? Any interesting guess? Yeah.
They can intersect but not be perpendicular?
No, so what I'm saying is I'm ruling out that option, okay? I'm saying that whether they are intersecting, when they are intersecting, I'm not trying to worry about the angle at which they are intersecting, whether they are intersecting like this, or whether they are intersecting like this, or whether they are intersecting like this. I don't want to worry about it. In any which way, they are intersecting. So there are two scenarios. One is when they are parallel, meaning they are not intersecting. Second is when they are intersecting, regardless of the angle. And there is a third scenario also. Yeah, Rian.
I'm not really sure, but is it when they're perpendicular?
Perpendicular and intersecting, I'm using that as one category. Yeah, Chris.
Could it be like infinite solutions, like where the lines are just like overlapping and
exactly? Yep. Yes, partner. So there are third scenario also. Hey, Rehan. So we just started, Rehan, so we have not missed anything. So we are talking about the linear equations, where we are talking about pair of linear equations, two equations, both are linear equations because the power to the variable is 1 in both the case. Now we are trying to explore what are the possible scenarios that we might come across when we are dealing with a pair of linear equation. One is when they will intersect. Second is when they will not intersect, when they are both parallel. And third scenario is when they will literally overlay each other or coincide, or in more mathematical intelligent terms you can say they have infinite number of solutions. Yeah? Is there a fourth scenario that you can think of? Let's not worry about it. There is no fourth scenario. Okay? There are three things: when they will intersect, when they will not intersect, and when they will over intersect, meaning they'll just overlay each other. Okay? Are you with me so far? Okay. So now, as I told in the beginning, any linear equation can be written in this form: ax plus by plus c equals 0. This is a standard way of representing a linear equation, where a is the coefficient of x, b is the coefficient of y, and c is just a constant. Okay? So if you try relating these here, in this case, this is a, this is b, and this is c. In this case, this is a, this is b, and this is c. Yep. So the three scenarios that we talked about, when they intersect, that is called a pair of consistent or a consistent pair of linear equations. Meaning when they intersect, they are called consistent pair of linear equations. When they don't intersect, when they are parallel, that is called inconsistent pair of linear equations. When they just overlay each other, they are just coinciding. So that is called coinciding pair of linear equations. So consistent, inconsistent, and coinciding. These are the three scenarios that we talk about. And we'll look at the mathematical aspect of it further. But at a concept level, if you say, when the lines are intersecting, meaning when you have two lines, when they are intersecting, that is called consistent pair of linear equations. When they are parallel or not intersecting, that is called inconsistent. And when they are overlaying each other, that is called coinciding pair of linear equations. Now you will say, why are we saying consistent? Consistent pair of linear equations. Now, when you have two linear equations, what is that we are trying to achieve? What is the main goal of having a pair of linear equations? Any guesses? I have two equations like this. See my favorite number 7. When I have two linear equations or a pair of linear equations, what is that one thing that always strikes us? What is that we are trying to achieve by having a pair of linear equations? Yeah? A common solution. See, when you have two equations with two variables each, your main purpose is to find out a common solution for common value for x and y. And when the lines intersect, that is the only scenario when you are able to get that solution. And that is why it is called consistent pair of linear equation, because two equations are helping you find out the value of two variables, and that you can achieve only by they both intersecting each other. And when they intersect, you get a solution. That's why it is related to the word consistent. Does it make sense? My magical formula is moment of silence. Just to confirm if you guys are with me. Does it make sense so far? Aryan, Chris, Sarah, Neil, Savya, Ritika?
Yes, sir.
Okay.
Yes, sir.
See what's up? You are with me? Dave?
Yes, sir.
Okay. So that is why it is given the term consistent. Something that is predictable, something that is not coming out of the blue. Meaning you have two equations, they are intersecting. That is how it helps you get the value of the two variables. That is why it is called consistent. And when it is inconsistent, meaning what? You have two equations and you are not able to use those two equations to find out the value of the variables. Not consistent. It's not helping with the purpose. Remember in the previous classes I talked about if you have two variables and two equations, you can solve and find the value. Here they are not meeting. This is not helping you with the cause of finding the value of the variable. This is not consistent pair of linear equations, and it's called inconsistent pair of linear equations. Does it make sense so far? Okay. So I will take a silence as a yes and move on. Now, as I said, my goal is not to tell you guys the same thing one more time. My goal is to give you guys some interpretive view of the pair of linear equations. Meaning, both the equations are following the same standard pattern. So let me get a little mischievous today and not try teaching you guys. Rather, I would poke you guys to get some answers from it. Okay. Now, when I have these two linear equations, which is all following the standard form, what is the possible scenarios? What is the possible scenario? How would you find out which pair is consistent, which pair is not consistent or inconsistent, and which pair is coinciding? Without solving it. Yeah, Chris.
Wait, are you asking us to like find like one of these three things if they're in standard form?
Yeah. So what I'm saying is, again, I'll make you guys think, okay? That you all know that this is a standard form for linear equation, okay? I have two linear equations following the same form. Obviously, I can solve this algebraically and find out if I'm getting unique value for x and y. That is meaning they are meeting at one point. Or I can plot the graph and see if they are meeting, then they are consistent. If they are parallel, not consistent. If they are overlaying each other, then they are coinciding. But I'm saying that okay, I don't want you guys to solve it using algebra. Neither I want you to plot the graph, but just by looking at the equation, can we come up with some ways to see which pair is consistent, which pair is inconsistent, and which pair is coinciding? Yeah, Pranit, you were trying to say something.
We could first look to the slope and see if the slope is the same, then that takes that consistent leaves you with non-consistent and coinciding. If they're different, then it's coinciding. And then we could also look at your y-intercept to see if it's coinciding.
That was pretty loaded information. I'll come back to you. Yeah, Ritika.
So we can determine like how many, if they are consistent, inconsistent, or coinciding by the number of solutions they have, or we could like just compare the variables and constants between them.
Right. So I'm saying that I don't want you guys to solve it and find out how many solutions they have. I don't want
But we
to
can
do that.
compare-
Yeah.
We can compare we don't have to solve the equations to find out how many solutions they have. We can just compare the variables. If the variable is same and the constant is different, then that means it will not have any solution, which means
So
it is
okay.
consistent.
So Ritika, just for the interest of the class, I would want you to go a little slow so that we all can follow you. Your teacher is going to behave like a fifth grader for next 10 minutes.
In a solution, there is variables and there's constants, right?
Yeah.
In the equation.
Okay, so let me keep hearing you and keep writing it here, okay, so that everybody can follow us. So here in this equation, let's call this coefficient as a1, b1 and c1. Here I'll call a2, b2 and c2, okay. So in this first equation you are saying, let me just put the value, okay, because I am not intelligent right now. So I'll just put the value by looking at the things here, okay, by comparing them. And my c1 is minus 7, okay. Here a2 is 2, b2 is 8 and c2 is 16. Now tell me, what do you want me to do?
If the variables are same and then the constant is different, then that means they don't have a solution.
How do you know that? See, x and y are variables. I have two equations with x and y,
okay.
right? So I mean, I don't have to say x and y are same or different. I don't know that, and we are not wanting to even solve that. We just know that I have x and y in this first equation, and I have x and y in the second equation also. So if you are able to solve it, then both x and y will have same value. If you are not able to solve it, then that's a scenario of this thing. But I'm not intending to solve it. I'm rather trying to look at the behavior or the property of these two equations to determine something.
Okay. So I don't, I know the way, but I don't remember it correctly.
Okay, anybody?
It's like so there's ax and by plus c, and then there's two equations in the same format. So I would compare the a value ratio with the b value ratio and the c value ratio. But I don't remember the relationship they have.
Okay, so let's keep peeling off the onions, right? That's the purpose. Now, a value ratio. So you're saying a1 by a2.
Yes.
So what is a1 by a2? It's 1 by 2. Okay, let's put it. Now b1 by b2. b1 by b2, b value ratio is 2 by 8 or 1 by 1/4. Yeah.
Yeah.
c1 by c2 is
It's 7.
minus 7 by 16. Yeah.
Yeah. I don't remember, like, you're supposed to have a certain relationship for it to be parallel or intersecting or like not inconsistent, but I don't remember the relationship.
But good thing is you are heading in the right direction. You at least gave me the clue to look at things with the right perspective. Okay. Now let's try drawing some interpretation. Okay. Let's pick up the things that are very simple. Okay, very simple. When you say two lines coincide, what it means? The equation is going to translate into one thing. If I have an equation like x plus 2y plus 8 equals 0, and I have 2x plus 4y plus 16 equals 0, essentially these two are same equation. Okay? Why? Because if you take 2 common here, it becomes x plus 2y plus 8. So this equation same. So if you are dividing or multiplying any equation by a particular value, you are essentially looking at the same equation. And that's the only scenario when your lines will coincide. What it means that if you look at these two equations, I said that these two are same, but let's not take what I said on its face value. What do you see here? By taking something common out, you get the same equation. Meaning, here in this case, a1 by a2 equals 1 by 2, b1 by b2 equals 2 by 4, which is the same, and c1 by c2 equals 8 by 16, which is essentially the same. So what did you see? When a1 by a2 equals b1 by b2 equals c1 by c2, you are essentially talking about same equation, and that's the only case when it will coincide. So this becomes your first interpretation. I picked up the easier one first, okay, so that we are able to relate things. Yeah. So from this one, if you look at these two equations, your a1 by a2 is 1 by 2, b1 by b2 is 2 by 8, 1 by 4. This is 7 by 16. This ratio of a1 by a2, b1 by b2, c1 by c2 is not matching. So they are not coinciding for sure. Just by looking at this line, just by looking at the ratio of the coefficients, you can say that they are not coinciding. Are you guys with me? And we will look at that ratio as Ritika said. Now I'm not a fifth grader anymore, okay? I'm a teacher. So that's why I'm trying to derive interpretation here. So here first thing we saw was, if the ratio of the coefficients or the corresponding coefficients, whatever way you remember it, coefficient of x, the ratio of coefficient of x is equal to ratio of coefficient of y is equal to ratio of coefficient of the C, then they are coinciding. So if you are given 3x plus 2y plus minus 7 equals 0, and then you are given x plus 2y by 3 minus 7 by 3 equals 0. On the outlook it might look cryptic, but then as soon as you look at it a little carefully, you see that between this equation, the only difference is here this equation is picked up and everything is divided by 3. So this is where the ratio of this guy and this guy's coefficient will match. So they are actually coinciding. Even if these two equations look way too different, but actually it's the same equation, which will lead to coinciding situation for this pair of linear equations. Is that one clear now? The coinciding one? Now, this part is clear, right? When they will coincide, you just look at the equation and see the ratio. If the ratios match, you are good. They are coinciding. They will have infinite number of solutions. When I say two lines are meeting at one point, they have one common solution, one agreement, which is one point which is meeting the agreement of this line and this line both. But when you say coinciding equations, you are essentially talking about infinite number of solutions. That is what Chris was hinting at. That if I have two lines which literally overlays each other, meaning they have so many points which are following the contract of both the applications. So that is the case of infinite number of solution or coinciding pair of linear equations. Did we drum this information enough now? Shall we move on? Yeah?
Yes.
Now, let's look at another scenario. This time we'll do a little bit of just 1 second. Ankita ji, I'm in a class. आप पैसे भेज दिए मुझे. हाँ. Sure. Sure, I will. Yeah. Okay. Yeah. Sure. All right. Yeah. Bye. Sorry. I was trying to disconnect the call, but all right. So now let's look at another scenario. Okay. Let's take equations like x plus 2y plus c plus 5 equals 0 and x plus 2y plus 7 equals 0, and let's try plotting it. Okay. So this is, let's look at the table for this guy. What happens? X, y, let's say when x is 0, what is the value of y? Minus 5 by 2. Okay. And when y is 0, x equals minus 5. Similarly for this guy, again, let's make the table x and y. When x equals 0, I'm just taking 2 points so that I can draw the lines. Okay? When x equals 0, y equals minus 7 by 2. And when y equals 0, x equals minus 7. So let's try plotting it on a graph paper. Let me create some real estate here. Now, this is my graph. Let's say this is 1, 2, 3, 4, or maybe 2, 4, 6, 8, minus 2, minus 4, minus 6, minus 8, 2, 4, 6, 8, minus 2, minus 4, minus 6, minus 8. Okay. Now let's try plotting this line, which says 0 and minus 5 by 2. So when x is 0, y is minus 5 by 2. It's somewhere, 5 by 2 will be here, minus 5 by 2 will be 2.5, so it will be this point. And then when y is 0, x is minus 5. So it's somewhere here. So this is your one line. Now let's look at this guy. When x is 0, y is minus 7 by 2. So when x is 0, y is minus 7 by 2, which will be like 3.5, somewhere here. Okay? And then when y is 0, x is minus 7. So when y is 0, x is minus 7. So what you, okay, this is where sometimes I get disappointed by myself. I wish I had better drawing skills. Okay. So now when you look at these two lines, though you will have your doubts in place for my drawing skills, but essentially if you look at it carefully, this is a classic case of a pair of parallel lines. See, this is meeting at minus 2.5 and 5. This is meeting at minus 3.5 and minus 7. And these two are actually drawing the parallel lines. Okay? So, if you look at these two equations, what is that is different? Only your C value is different. And if you look at this one, minus 2.5 and minus 7.5. Minus 2.5 is whatever. Minus 2.5 is minus 2.5, sorry, minus 2.5 and minus 3.5. The distance is 1 unit, okay? 1. And that, here also if you see, this is minus 7, minus 5. So on this place, this distance could be what, okay, anyway, don't worry about this please, this is different. So that what I'm saying is, this is plotting a pair of parallel lines. Okay, and only the C is the reason for this one. Meaning, the ratio of the coefficient of x and ratio of coefficient of y are same. What is changing is only this part. So I know this might be sounding a little confusing, but let's look at it carefully what we did. Okay, so we took this equation. In both the equations, what I did purposefully was I kept x and y part same, and I only changed the c, the constant part. And when we plotted this one, this is plotting a pair of parallel lines. So from this one, you can see that both the equations are same, exactly the same. Only difference is the constant part, the c. Yes, sir, what's up? Yes, sir, what's up?
Sir,
Mm-hmm.
that was a mistake.
I'm sorry?
That was my mistake.
Okay, not a problem. So I'm saying if you observe this carefully, only thing that has changed was the value of C. So that led to drawing a parallel line. Now you will say, first of all, your drawing skills are horrible, and then you are making us believe that they are parallel lines, and which is not very trustworthy, and that I'll agree to. Now there's a mathematical way of getting an agreement on this one. Now you also know that you can always write the equation in this form, right? This is called slope-intercept form, where this is your slope, yeah? And this slope is nothing but your how your y is changing for every change of x, yeah? So if you if you want to convert this into y-intercept form, let's look at these two equations. You can convert this equation into both the equation to y-intercept form and see what is the intercept. So here 2y in the first equation will be equal to minus x minus 5, or y will be equal to minus x by 2 minus 5 by 2. If you look at this equation, if you convert this into y-intercept form, this will become 2y equal to minus x minus 7. So y equals minus x by 2 minus 7 by 2. Now this is your m. This is your m. Look at both these equations. Both have the same slope. When you have two things having the same slope, that is when they are parallel. If this line has the same slope and this line also has the same slope, that is why they are parallel. So mathematically, without relying on my drawing skills, if you look at the mathematical side of it, if you convert any linear equation to slope-intercept form and find out the slope, you will find that their slope is the same. At least for this equation. So that is why when you are looking at two equations where the slope is same, meaning when you convert that to slope-intercept form and you find the slope is same, that is when you will say that they are parallel. Now, parallel meaning inconsistent pair of parallel lines or inconsistent pair of linear equations. Yeah? Is it confusing so far?
No, sir.
No, sir.
Okay. So let me just summarize this for you guys. What we did and how do we relate. So first thing was the coinciding line, where you just have two equations, you pick one equation, multiply by something or divide by something, you get the second equation. That is when it is translating into one line and they coinciding. So that part was easy. Meaning when your A1 by A2 ratio is same as B1 by B2 ratio is same as C1 by C2 ratio, this is coinciding line. This is coinciding. In the second case, what we did was we picked up two equations and we tried plotting them. We had the equations like this and this. We just tried plotting them and we found that that's a pair of parallel lines. But as always, you guys don't trust my drawing skills. So that is why we looked at it mathematically and tried relating this in slope-intercept form, which is nothing but y equals to mx plus c. So if I have equation like this, if I convert into this form, what is the value of, what will be, how do we represent that in this form and find out the slope? Same thing, this guy also write in this form and find out the slope. And we saw that both have same slope. When two lines have same slope, that is essentially when they are parallel. Yeah? So, when will they have same slope? Now you look at these two equations. A1 by A2, B1 by B2 are same, but C is not. That is when they become parallel. So when you are talking about parallel lines or pair of inconsistent linear equations, what you are saying is my A1 by A2 is same as B1 by B2 but is not same as C1 by C2. See, now what I will do is I'll just extrapolate this and so Ritika, after today you will not forget this, okay? See, for what I did, coinciding line, everything matching, all ratios matching. Inconsistent line, we found that C1 by C2 is not matching. So last one we did tic-tac-toe. We knocked off one ratio. Now, when you talk about consistent lines, no strike off. One striked off, two striked off. Done. Does it make sense, everybody?
Yes, sir.
Yes, sir.
So basically, if you relate this, here, this is the same equation, that's why your ratios are matching. Here, your C value is your determinant, okay? If the C values are, the ratio of C1 by C2 is not matching with any of these, then it's forming a parallel line. And this ratio should not have any relationship. If the ratio of A1 by A2, B1 by B2 and C1 by C2 is not matching, that's the situation when you are enforcing the lines to meet somewhere. Okay? And we can try doing that in any equation, okay? Let's pick up one random equation, okay? One random pair of equation and then we can relate. So let's say I will say x plus 3y minus 2 equals 0 and 2x minus y plus 7 equals 0. Okay? What my formula says, this ratio should not have any relationship. Let's see what does it say. A1 by A2 equals 1 by 2. B1 by B2 equals minus 3 by 1 or minus 3 by 3, whatever you say. And C1 by C2 is minus 2 by 7. They have no relationship. They are from different families. No connection. So I'm saying that this will coincide. They will not coincide. They will intersect. Now, this was just the theory part of it. I just wrote this theory here. Now we are going to just try solving it quickly. Okay. So this will form a table. Let's look at two values, x and y value. In this case, when x is 0, y is 2 by 3. 0.7 or 0.666, whatever you call it. When y is 0, x equals 2. Okay. This guy, when x is 0, y is 7. When y is 0, x is minus 7 by 2. Let's try plotting it. 2, 4, 6, 8, minus 2, minus 4, minus 6, minus 8, 2, 4, 6, 8, minus 2, minus 4, minus 6. See, I keep bragging about myself, right? Never be shy when it comes to doing scratch work, okay? Never be shy when it comes to practicing. Never be shy even if you have to solve the problem 5 times. Because that is how the proficiency with math will come, okay? And you'll not be afraid of solving a problem. What if you go wrong? Let it be. That's fine. Now here, 0 and 2 by 3. So when x is 0, y is 2 by 3. 2 by 3 will be somewhere here, between 0 and 2, okay? When x is 2, y is 0. When x is 2, y is 0. Join these two. It's a straight line. Now, when I pick up this one, when x is 0 and y is 7. When x is 0, y is 7. Okay, this is somewhere here. When x is minus 7 by 2, x is minus 7 by 2, it will be somewhere here, 3.5. Y is 0. So this is the line. These are 2 points, this point and this point. They have to intersect, they don't have a choice. Yeah? So, all that I am doing here is just to ascertain that whatever we saw with this relationship, consistent pair of linear equations, When they are coinciding, all the ratios are matching. When they are inconsistent, meaning when they are parallel, only C goes for a toss. Everything else is matching. When they are consistent, I strike off all the ratios. This is my best bet. If this is the situation, there is no ways the lines can be parallel or coinciding with each other. They have to intersect. You are bound to get one solution without any second doubt. Does it make sense?
Yes, sir.
Now time for waking up everybody and checking if it is understood. Chris, Ritika, Sarah, Neil,
Yes, sir.
yeah?
Yes, sir.
Srivatsav, Shravya.
Yes, sir.
Okay. So now coming back to Ritika. So Ritika, do you think we will come across a situation when even if you know what is your starting point, you might get stuck? Do you think we will still have that scenario or that possibility, or we are better off now?
For me, I find it like I've been learning this for a while now, but sometimes I can understand coinciding, because coinciding, the lines are on top of each other, so they all have to be equal. But inconsistent and consistent, sometimes I mess up the ratios. But it's okay now.
So see, this is my teaching is, as I say, right? When I'm asking you guys to teach me something, I say that okay, pretend that I'm a fifth grader. I mean, with due respect for every fifth grader, okay? I'm saying that you have to always look at how do you make it look so very easy that even a child can understand. That should be your approach. Till the time you are not able to comprehend something in a simple way, it's very likely that you also might get stuck somewhere. So now here, with whatever I did, there are a lot of things that I had not learned, okay? I just looked at the conceptual part of it. While I was trying to do it, I was kind of relating or connecting the dots, okay? And then now, with this, I have put this across now. Then okay, this ratio is what matters to me. Coinciding, all matching, inconsistent, only C being the outlier, consistent, everything being outlier. Meaning it's like a scalene triangle, all sides different. Isosceles triangle, only two sides matching. Equilateral triangle. I know that's a bad analogy, but I'm saying this is how you relate. So for lines to intersect, you have to make sure that they have no relationship among themselves. The coefficients are so very unique that you will never come across anything that makes it sticky. Only C is helping you move the line up or down. Okay, if you have to look, imagine if I say that you have a linear equation which is x plus 3y minus 2 equals 0. Shift this linear equation by 2 points. Meaning, let's say if this is drawing this line, if I want you to shift this line, right? Okay. This is something that you will probably do later on when you learn the design principles, when you talk about engineering drawing and those stuff. When you have to move something, like in case of parabola we have learned, right? How does the parabola move left or right, up or down? Similarly, if I have to move this line vertically by 2 points, I know that I have to play around with this. It will remain parallel to this and shift. Yeah. So this is where visualization or what do you call or animation kind of thing will come into picture. If you extend this understanding to the next level, where those people who create animations, they essentially deal with a coordinate plane, and they have to look at, okay, if I have to make Birendra Kumar looked little more fat, I have to move these points, let's say by 5 inches more, both sides, or extend this shoulder by 5 inches both sides. That's what we are talking about. Move this line by this much. I know it was a little bit of an overdose of things that you may or may not come across, but I was just telling you. I mean, whatever we are learning, this is the core of what you will do in future. So if you understand this, if you are able to relate this, you'll be able to play around with this. Yeah. Any questions? No? Now, in next 5 minutes, let's try learning something equal to everybody knows. Inequality, I just want to quickly check if you guys are clear about things. Now, if I say 4x plus 3 equals 8 or 3y equals 8, easy, right? I mean, it's a contract between x and y. 4 times the value of x plus 3 times the value of y will give you 8. If you play around with x and decrease the value of x, this value increases because the sum has to be this much. If you increase this one, this value decreases to match with this one. That part you know. What happens if I say this is greater than 8? Or I say this is less than 8. Or I say this less than equal to 8. I see some kids from the next class also have started joining. I will not make you guys wait longer, but yeah, let me just take 2 minutes to make sure that we are clear with the concept part, and if there is something that needs to be double clicked, we'll do that in the coming classes. But if I'm talking about equal to, something which is not equal to, meaning greater than, less than, or greater than equal to, or less than equal to, those are the scenarios which is called inequalities, meaning not equal to. Yeah? If I'm talking about, let's say this equals 8 and this plots a line like this, let's say, meaning x and y value, every point on this line, the value of x and y together will get you this much. If I'm talking about something greater than 8, what would that mean?
It gives you a range of answers.
Meaning you're talking about every point outside this line, be it above or be it below, that we'll figure out. Any point above the line, pick up the x and y value, substitute here, that will give you greater than 8. Essentially, greater than scenario, it will be above this. If you're talking about less than scenario, you're talking about all the points. So you're essentially not talking about this line, you're talking about the region. Every point in this region, excluding this line, you just pick up any point in this region and that x and y coordinates value substituted here will give you a value less than 8. When you're talking about greater than 8, you're essentially talking about the region above this line, excluding this line. When you make it less than equal to, then that line is also included. I'm just trying to do a recap. I'm pretty sure you guys already know about this. I was just trying to make sure that this part is not overlooked or missed out. Any questions? No questions? Tired of